Hi, I'm Rex Black, President of RBCS. Welcome to the RBCS YouTube channel. Hey, I hope you enjoy all these free resources that are available here. And do us one favor. We need to keep the lights on and we need your help to do that. So, when you need testing and quality related services, training, consulting, expert services, you name it, let us be one of the bidders on that next job. We don't expect to get all of your business, but we'd like to get a chance. Thanks and enjoy the shows.
On behalf of RBCS, RBCS New Zealand, RBCS Australia, Software Test Works, and Software Test Professionals, we welcome everybody today to this webinar on testing metrics. I am Rex Black. I'm President of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, RBCS has been both a pioneer and leader in quality hardware and software testing. We have offices in the United States, New Zealand, Australia, and Sri Lanka, and partners around the world. RBCS delivers insight and confidence to our clients, helping them get quality software and hardware products to market on time and with a measurable return on investment. RBCS has a team of international consultants to deliver customized training, consulting, and outsourcing services for companies that are looking to improve their test and quality assurance practices. RBCS has helped hundreds of companies reduce development and support costs while assuring the best quality products are delivered to customers. I'm the author of Pragmatic Software Testing, Advanced Software Testing Volumes 1, 2, and 3, Foundations of Software Testing, Critical Testing Processes, and Managing the Testing Process. I hold a degree in Computer Science and Engineering from UCLA. I'm also past president of the International Software Testing Qualifications Board and the American Software Testing Qualifications Board. RBCS is presenting this webinar in partnership with Software Test Professionals. In addition to our ongoing collaboration on webinars and training, I will be the opening keynote at the Software Test Professionals Fall Conference on October 25th in Dallas, Texas. Hope to see some of you there. In addition, if you haven't visited their association website, make sure to check it out as well, www.softwaretestpro.com. Before we start the presentation, a couple of housekeeping notes. If you have any questions during the course of the webinar, please feel free to submit them at any time via your webinar interface. There is no need to ask for copies of the presentation. The presentation is on the web, www.rbcs-us.com. Go to the Resources tab, find the Basic Library page, go all the way down to the bottom, and there it is. There is no need to ask how to register for the free e-learning. Just by attending this webinar, you are registered. Check your email over the next couple days and watch the spam filter to make sure the notification doesn't get caught in there. You do have a limited amount of time to respond if you are a winner. And if you are having any problems with either the audio or visual components of this webinar, please contact GoToWebinar support. If for whatever reason you cannot get to the webinar online, or if you're dealing with an unreliable connection, please download the slides. As I said, rbcs-us.com, Resources tab, Basic Library at the bottom. And be sure to use telephone to connect rather than voice over IP. This afternoon, I made a bold comment saying, oh, we almost never have problems with voice over IP, and then right in the middle of the Q&A session, my audio driver on my voice over IP dropped, and people were left hanging for 4 minutes. So it does happen sometimes. Be ready for all eventualities. I hope you enjoy this free webinar from RBCS. We do these free webinars as a service to the software testing community because at RBCS we are a not just for profit company. So today's presentation is on testing metrics. Now, metrics are widely used and testing metrics are also widely used and typically to make project decisions. But what we see with a lot of our clients is they make some fairly easily avoidable mistakes, and that leads to misunderstandings and, of course, bad decisions proceed from misunderstood data. And I also see that not as many people who really should know do know how to use testing metrics to understand the capabilities of their software process and the quality of their products. So in today's webinar, we are going to look at how to do those things. Okay. Now, by training, I'm an engineer. I have a degree in engineering, as I mentioned, from UCLA. And so I like to manage with facts. I like to manage with reality. And, metrics let us do that. So metrics can help us understand where we are in the project. Metrics can help us understand the capabilities of our process and improve it. Metrics can help us understand what our product is like. There are various uses of metrics, and we're going to look at a number of them here as we go along. Now, let me start off with this question that comes up. Well, why metrics? I mean, couldn't we just, just watch what's going on, sort of based on, or we think a lot of tests are failing, yes or no? Do we think we're seeing a lot of bugs, yes or no? Couldn't this all just be done kind of subjectively without any sort of measurement? No, not really well. Like I said, manage with facts. Don't manage with opinion. Don't manage with gut feel. Your gut will lie to you. Your gut will tell you things that sound reasonable that are actually wrong. My favorite historical example of this is Aristotle. Aristotle, smart Greek philosopher from 2,500 or so years ago, said a number of very smart things, but one of the things that he said was that heavy objects fall faster than lighter objects. And for about 2,000 years, people believed him. And then at one point, somebody, I think it was Leonardo da Vinci or some other really smart Renaissance man, decided to climb up in the Leaning Tower of Pisa and drop 2 cannonballs of different weights off of the Leaning Tower at the same time. And he observed that they hit the ground at the same time as well. So much for 2,000 years of commonly accepted understanding of speed of falling objects. And, I mean, the thing that's stunning about this is it is so easily disproved, and even in the context in which it was originally said. I mean, it's not as if Aristotle lived in the middle of the Midwestern plains of the United States or something, and a good cliff was hard to come by. I mean, he lived in Greece, for gosh sakes, I mean, there's no shortage of cliffs. He could quite easily have walked up to a cliff with 2 different weight rocks and dropped them and observed that, indeed, they both hit the ground or the water or whatever was underneath at the same time, thus disproving his conjecture. So, the moral of the story is don't trust your gut and trust data, trust measurements. Measure to know, because what sounds reasonable to you can easily be wrong. And in fact, it's the reasonable sounding wrong idea that's the most dangerous kind of wrong idea, because a wrong idea that sounds stupid is harmless. I mean, people just go, that's really stupid. I don't believe that. But the wrong idea that sounds reasonable will have followers and will mislead people. So measure. Now, I believe this is particularly important for testing because testing by itself has no value. Just sitting in front of a computer and pecking away on it and observing whether what happens is what you expected to happen, that by itself, that has no value. That observation, the information gained, has to be connected to some audience that needs to know either that information directly, like which test passed and which failed, or some summation of that, some analysis or a summary or something like that. But that information has to get passed along to people. It's got to be generated, and it's got to be communicated, and it's got to be communicated effectively. There's no good having potentially useful information and then not communicating it effectively. A tragic example of this took place a number of years ago. What was it, about 15 years ago? The United States space program Challenger disaster, when the Morton Thiokol engineers actually knew pretty much that the O-rings on the solid rocket boosters would not perform properly in the freezing weather that had taken hold of Florida that weekend. They attempted to communicate that information to the NASA managers and the Morton Thiokol managers to try to convince them to scrub the launch. Their communication, while the data was there in their presentation, it was not communicated effectively. NASA decided to go ahead with the launch, and at that point, the tragedy was ensured, and indeed the next morning the solid rocket booster burned through the brittle O-rings, brittle because of the cold weather, exactly as the engineers had thought it would, and spewed a jet of fire out directly onto the liquid hydrogen tank, blowing it up and killing all of the astronauts in space shuttle, as well as destroying the shuttle itself and all of the other sundry parts of the booster that were there. So, don't. It's not enough to just have information. It's also important to communicate it. Now, this presentation is not so much about communication of results. We'd had a webinar on that previously, and we'll have another webinar coming up in summer about psychological aspects of test management, including communication of results. So I don't want to get too far afield, but I do want to point out that while we are focused on metrics here and effective creation of metrics, remember that communication is part of the puzzle too. So now when I'm talking about communicating this information via metrics, we can have various goals there. We could be wanting to just notify people, okay, here's a fact. We might want to enlighten people, to draw their attention to some aspect of the process or project or product that we think is worth them knowing about, and potentially also even influence them to try to convince them to take a certain course of action. If you're trying to influence, notice that you have to first notify and enlighten. So that's sort of a cumulative type of situation there. Now, the metrics that I'm talking about, these can be part of your regular status reports, your test status reports and projects, or they can be part of some sort of periodic or as-needed analysis. I'm going to cast the net pretty widely in terms of metrics. Excuse me. Now, so let's talk. Let's start off by talking generally about how we can develop good metrics. Now, let's start actually first by looking at how not to develop metrics. Here's how not to develop testing metrics. Take whatever reports your test management package produces by default, spew them all out into some sort of JPEG or HTML or something like that, zip them up and email them to everybody on the project. Unfortunately, that is something that happens quite a bit. That is what I call the fire hose of data problem, where all sorts of confusing, irrelevant, and overwhelming data and detail is sent out to all and sundry. And of course, no one even bothers to look at it because they have no idea what to do with it. They get used to getting a 5 meg zip file from somebody every day, and they just kind of go, whatever, it's not even going to look at it. And I'm not saying that this is a testing sin specifically. This is a general management error that's made. Usually people who've been in management a while learn not to do this, but it is not unusual for people in their first few years of management to just think that over-communication is great, send out all sorts of data and, be transparent and so forth. But people don't want that. People want to get what they need to get. So let's talk about that. How do you understand what people need to get? Well, first off, to develop a metric, think about the project, the process, or the product that you're looking at. And I'm going to get into a little more detail on that a little later, the distinction between them. But hopefully you get that just generally from the words that make sense to you. So you got a product, you got a process, you got a project, and so you're doing something. And you have objectives for that. You have objectives that you want to achieve. Then ask yourself for any given objective, okay, what would it mean to be effective at this? What would it mean to do this efficiently? What would it mean to be elegant about the way I went about this so that it actually satisfied the people, the stakeholders who have an interest in these objectives and their achievement? Now, I want to briefly digress. Let's just make sure I'm clear on what I mean by effectiveness, efficiency, and elegance. So effectiveness is, are you actually carrying out the objective? Sort of the brute force kind of thing. You got an objective, are you doing it? Or more accurately, really, usually, to what extent are you achieving it? Now, efficiency has to do, to some extent, with effectiveness, but more about cost effectiveness. It has to do with, given the resource, the time, and the money being expended on achieving this objective, are we doing it in a relatively lightweight fashion? Are we getting a lot of bang for our buck, I guess you could say in the colloquial phrase? Now, elegance has to do with, does this look graceful when we do it? Does it look like we know what we're about? Or is it like a sort of swirling tornado of chaos and we look like a bunch of bumbling idiots? And maybe we produce the right result, but it certainly doesn't look good. Kind of like the German Chancellor Bismarck's comment about those who respect the law and enjoy eating sausage should never watch either being made. If people like our testing, it's not like we can just say, well, stay out of the test lab and pay no attention to the man behind the screen. We don't want you to see any of this stuff. We're going to go off and do this, without any visibility. Well, that's not the case. I mean, your testing tends to happen as part of a project, and the process is visible to people to a greater or lesser extent. So, does it look like we know what we're about? Okay, so effective, how effective are we? How efficient are we? How elegant are we? Then, based on those questions, we then say, okay, well, how would we, what kind of metric could we put in place for this, and is it measurable? Now, in some cases, you say, I actually can't answer this question directly, but there's something really related to it that I can answer that tells me indirectly the answer to this question. That's called a surrogate metric, and we'll look at examples of surrogate metrics later. So, now, having devised a metric, then you would set a goal or target for each metric. Now, I confused someone this afternoon with the word goal, so English wasn't his native language. He's like, well, what exactly do you mean in the difference between objective and goal? And to me, the objective is some general thing, and the goal is specific. But maybe target works better for you. So, if you prefer the word target, think of target. And I'm going to give some examples of this. Will help kind of illustrate what distinction I'm making. Now, based on that goal, one of the things that you might want to do is actually improve over time, get better at your effectiveness, your efficiency, or your elegance. So that's something that you might want to do over the long run. And again, we'll look at some examples of this as we go along. All right, let's start with one. This is a project, example of a project metric that we're going to derive here. So we have an overall objective for a project, typically with testing work going on. We want to find defects, right? When we're running testing on a project, we want to find defects. And generally, we want to continue that until we feel fairly comfortable that we've found all of the defects that matter. And so what you tend to look for is a leveling out of the defect arrival rate. And also that the defects that you have been found have been fixed, and that you've confirmed them as fixed. And that's something called convergence. We'll see an example of this later. I'll show you a chart where we look at achieving convergence. You're going to look at the trend over time. Do the defects level out? Do the fixed defects intercept the discovered defects eventually? And we can say that we're done from a project point of view, at least with the defect finding objective. Now, in the long run, one of the things that you could do is you could say, I look at the shape of my defect finding curve and the trend curve, and it's, I find defects too late in the testing. I want to find them earlier. I want to find them right away. So that's an improvement that you might put in place, and then you could watch to see if you actually did shift the cumulative defect discovery curve to the left during your projects. And again, I'll show an example of this here shortly. So here's another example, confidence. We want to have confidence when a project is kind of winding down and testing is concluding. We want stakeholders will want to have confidence that the product, if put into production, is not free from bugs, of course, because realistically we can't guarantee that with testing. We can't find all the bugs, but we should be able to build up a level of confidence that says, you know, we feel pretty good about putting this in production. We think it's been thoroughly tested. Think the kind of problems that we would have missed are things that are probably kind of off the beaten path, relatively low risk. So we want to have confidence. Now, confidence is hard to measure directly because, you know, well, there's two problems with it. One is, what are you going to do? You're like going to start, you know, sampling the dopamine levels in stakeholders' brains while you're giving your project status reports. You're like, oh yeah, everybody's got a good dopamine release going there, so they're feeling good, and therefore they must be confident. You know, if they have a dopamine release rather than a panic attack during test status reporting, then that's a sign of confidence. Well, no, you're not going to do that because you're not going to be able to monitor that. And even if you could, that's actually the wrong thing because you might very well be measuring false confidence rather than true confidence. So true confidence is based on, you know, an actual true understanding of where you stand. And so the surrogate metric that we typically recommend to be used for measuring confidence is coverage. Now, when I say coverage, this has got to be one of the most overloaded terms in software testing, right up there with test plan and test case. In terms of it, you know, it can mean a bazillion different things. But anyway, when I say coverage, I'm talking not just code coverage, which is what some people mean. And in fact, for system testing, system integration testing, code coverage is not really the most meaningful thing to look at. It's good for unit testing and to some extent integration testing, but you get up into the higher levels of testing like system test, system integration test, really you're more interested in requirements coverage, risk coverage, supported configuration coverage. If you've got major types of data that you deal with, data type coverage. You know, so coverage is coverage of the stuff that matters, basically coverage of the things that your tests are based on. So this is a multidimensional kind of metric that we could look at here, but one of the dimensions of it we could say from an effectiveness point of view, do we have any requirements that have known, identified, active failures against them? Because as long as that's the case, we can say, you know what, we know we haven't satisfied the requirements yet, and so our level of confidence should not be high until we've satisfied the requirements. So from a metrics point of view, we could classify the requirements as you know, completely tested without any failures at all. So we are very confident that that particular requirement is met. Or we could say the requirement is it's been tested to some extent and we have found failures in it. So now we don't have confidence. That's sort of anti-confidence, in the sense that we know that there's a problem, but at least we're starting to know where we stand. And then there's the requirements that are actually completely untested, that we haven't tested at all. Of course, we have no confidence in those. We have no idea where we stand on those. So we can look at the percentage of again, the sort of green requirements, we could say, the ones that we're comfortable with and we've tested them where we think, okay, we're good here. The red requirements, which are the ones where we say, yeah, you know, we've tested this and to some extent and we know we have some problems. And then there's the requirements that we're sort of in the black about, that we don't really know, that are untested. So we could have, you know, percentage red, percentage green, percentage red, percentage black. And as long as the percentage of red and black is greater than 0%, then, you know, that's a sap on our confidence. Ideally, you'd want to say that before we get done with a project, we've hit 100% requirements are green status in the sense that they've been tested and there are no must-fix failures. Now, in terms of an improvement, going from one project to the next, what you could do is you could look at historically, you know, what percentage of requirements did go green or go red, excuse me, at one point or another during testing. So that's stuff that came to you not done from a test point of view. And if you wanted to make the testing go faster, it's usually the one of the major causes of the delay in the completion of testing is failed tests. If you want to make the testing go faster, then what you would do is look at ways to increase the number of requirements that are in good shape. And when you get the testing, when you get the release, which would be the same as saying reducing the number of requirements that fail on delivery. Generally, that's going to be through some sort of enhanced form of upstream testing, like unit testing or integration testing. Though it could also involve, of course, better requirements, better design, better code reviews. Okay, so we looked at defining metrics in general and looked at a couple examples of them. Let me go back to this theme of sort of in general, speaking in general for the moment, and then we'll go back and drill into some more specific examples here once I get this out of the way. But I think it's important to say something I alluded to earlier. Good metrics would be useful, pertinent, and concise. And this is true of testing metrics and quality metrics, any metric really. But now when I say useful, what I mean there is that it's connected to an objective, as I mentioned before, that you could look at this metric and go, okay, based on this metric, there's some decision I can make and potentially some action that I could take that would be driven by this metric. It's not trivia. It's not something you look at and go, oh, gee, isn't that curious, and then it's completely inapplicable to everyday life, like a Fibonacci series or something like that, where you might know it, it's a Sudoku or something, it might amuse you in some way, but it is not useful. Remember, engineering is about building useful things, and we've got to have useful metrics to help us build useful things. So, useful is part of it. But it's not enough to just be useful in the sense of connected to some objective. It also has to be pertinent. And what I mean by that is it's connected to an objective that the person looking at it cares about. That they say to themselves when they see that, yeah, that's something that matters to me. That objective and whether it's met, how well it's met, how efficiently it's met, how elegantly it's met, that matters to me. So it gets people's attention. And it also needs to be, your set of metrics needs to be concise. Again, the fire hose of data problem is something we really want to avoid because you can have a lot of good information, but if you just go on and on again, the same objective addressed from 27 different points of view with 27 different metrics, you're going to lose your audience. Hit the nail once and on the head. Don't beat around the nail a million times with a hammer, is I think the important thing to keep in mind here. If you create these large sets of metrics, it's not only a lot of work for you, it creates a lot of measurement overhead, which is bad. You as a manager or as a tester, time you spend measuring is of course time taking you away from other things that you need to do. So I'm not saying this isn't valuable, but I'm saying this has to be seen as a balance. You spend the time on it that it deserves and no more. So don't create a lot of measurement overhead by having a huge number of metrics. And also remember, you will lose your audience. Attention spans are limited, especially amongst the more senior people. So say it once and say it right, rather than saying it a million times with a million different metrics that beat around the bush. Also, and I don't want to get into too much into psychology here, because again, we're going to deal with that in an upcoming webinar, and I think it's the July webinar that we're going to deal with this. There's a couple psychological things that you need to be aware of with respect to your metrics. Now, one of these is what's called cognitive dissonance. Cognitive dissonance is tendency for people to have a really hard time processing information that surprises them, that they are not expecting. And the other psychological thing that needs to be taken into account here is what's called confirmation bias. Now, confirmation bias is somewhat like cognitive dissonance. People tend to easily accept information that confirms what they already believe. They tend to look for sources of information and look for ways of interpreting information in a confirmatory sort of fashion. And what this means is that if there are different ways of interpreting a metric based on how it looks, don't be surprised when people don't interpret it the right way, but they interpret it in some way that's consistent with what their own personal goal for the project, product, or process is. So if we were talking about a project manager who's very much focused on a deadline, it's going to be difficult to make the case that the defect arrival rate, for example, is such that we're not going to hit that deadline. So you have to be ready to explain this stuff in great detail, logically argue your case. The metrics are facts, but they're not. Often facts can have different sorts of interpretations put on them, and you need to be ready to help people put the right interpretation on the set of facts. Now, I was a little bit dismissive earlier about the automated test management tools, and I want to make sure that I'm clear about what I'm being dismissive about. I'm not saying that the automated test management tools of various sorts, be it Quality Center or any of the others, are worthless, not by any means. I mean, from a metrics point of view, they are very good at capturing all the sort of constituent data that you need for your metrics. At least many of them can be. The thing that they're not so good about is reporting. So, make sure that you, when you're thinking about how you want to present the metrics, rather than just gathering up the raw data that makes up the metrics, that you transcend the tool. So use the tool to gather up the constituent parts, things like traceability between the requirements and the tests and their status, traceability between the risks and their tests and their status, and the risks and the bug reports, and the bug reports and the test cases and their status, and all that stuff. You want to set up to gather that information for sure. Just understand that when it comes to actually reporting it, you're probably going to have to do a fair amount of massaging, often by dropping it into Excel. And yeah, the point of all of this is, enlightening, informing, not confusing or misdirecting. One of the questions that we ask when we do assessments is, this is of non-testing stakeholders, do you understand the test results in the form in which they are reported to you? In other words, when you get your test results reports, do they make sense to you? And does that understanding help you manage the project or process or product to success, whatever they're involved in managing? Now, it's interesting. We will get, as the answer to this question, more frequently than one would like, for sure. Either, no, I don't understand the results based on the reports, and of course then, no, I can't, that doesn't help me manage. Or you get, yes, I understand them, but no, it doesn't help me manage. Now, you might say, well, that's weird. If they understand them, it shouldn't help them manage. Well, this gets back to the useful and pertinent problem. If we're giving people information that is not useful, or maybe it's useful but not to them, so it's not pertinent, then that's not going to help them manage. So it's got to be useful and pertinent, and it has to be understood. So make sure that that's your goal, what you're striving for. Excuse me. Now, in terms of how to present information, again, we had a separate result reporting test results reporting webinar, and I don't want to rehash the same ground. If you're curious about this, and you didn't catch it, go check it out on the digital library. But just to say briefly, in terms of presenting metrics, one of the options is to present a snapshot of status at a moment in time. And this is typically something like a table or just a single number. It's like, okay, this is our measurement right now. When you're looking at your dashboard on your car, a lot of the gauges there are snapshots of current status, of speed and current amount of gasoline and so forth. So they are just, here's where you stand right now. And when you're driving a car, that's pretty much what you need to know. You don't really need to know, efficiency and okay, what's my trend in terms of mileage and so forth. I mean, not in real time, because that's not pertinent to safely operating the vehicle. But in some cases you do need to know trends emerging over time, and so there are plenty of metrics where you do present them as a trend chart. So a trend chart is any chart that has as its Typically, the horizontal or x-axis is time. And the vertical axis on which one or more data points are plotted is defects, or the number of past test cases, or the number of requirements that are green, red, or black based on the scheme that I mentioned earlier, that kind of thing. Now, a trend chart is great because it can show you, where we're headed, and that's very useful, but it doesn't tell you why anything is happening. So another type of chart that you might create is a causal or relationship chart, like a scatter plot, check relationships between two variables, or Pareto analysis to look for defect clusters or something like that. So you really want to think about what's the right way to present the information. Now, as I said, I talked about this in the results reporting webinar. If you're interested just in general, a guy named Tufte, Edward Tufte, has written this whole series of books. That's Tufte, T-U-F-T-E, on good graphical displays of information of various sorts. In fact, the first book is called just that, Graphical Displays of Quantitative Information. In spite of the extremely dry title, is a very engaging book and is truly perspective altering. You'll never look at another presentation of information the same way again after you read Tufte's books, so I recommend those. Okay, so now let's go back, kind of come back around to this question of some metrics and types of metrics and examples of each type of metric. So let's start out with process metrics. So when I talk about a process metric, we have a lot of processes in testing. You've got defects management process, you've got the test environment configuration process, you've got the test case, test data, et cetera, creation process, you've got quality risk analysis process if you're doing risk-based testing, you've got an estimation process, results reporting process, and so forth. So we can identify all these various processes that we have, and then we can say, well, let's put some metrics in place to see how effectively, efficiently, and elegantly we are carrying these processes out. And of course, based on that, we might decide to institute some improvements. Now, if you were to have ever had a assessment from us, from RBCS, you know that we use a framework called the Critical Testing Processes, or CTP framework, and we specifically use metrics in our assessments. As again, manage with data, right? We want to manage with data. So certainly when we're making process improvement recommendations, we would have a lot of process metrics, and it depends on the size of the assessment, but certainly we can have dozens of metrics that we can look at. Too numerous to list. So this is, I think, a good thing to do. Have some process metrics, identify your critical testing processes, put some effectiveness, efficiency, and elegance metrics around those, and measure. And then if you find that you fall short of industry averages or just where you want to be, then set some goals for improvement and make those. So examples. Well, wait, before we get to examples, let me cover one other thing. So just to put this in context, I talked generally about good metrics, and just to be specific about process metrics, you want to make sure that you look at, what are our critical testing processes, and make sure you focus on the critical ones, right? I mean, looking at stuff like does the phone system route phone calls to the testers efficiently? That's probably not top on the list of things that get in the way of you doing your job. So critical test processes, and then define the key objectives for those. Now, those can be things like finding bugs, right? I mean, so look at the bug detection overall is important for testing. So do we find bugs? And do we find the important bugs more heavily than the unimportant ones? Do we reduce quality risk? Do we build confidence? Do we provide useful, enlightening information? So, define your objectives, decide the effectiveness, efficiency, and elegance questions that you need to be able to answer to know, how well these objectives are being met. create your metrics to address those questions as mentioned before, and then set your goals. Either, ideally what you would do is benchmark yourself, like say, okay, here's where we are now, and then you'd say, okay, where do we want to be with, relative to industry averages and other kinds of things, and then crank it up. Look for ways to improve your process. So now we'll get some examples here. So let's start off with bug finding effectiveness. So typical objective of the testing process overall is finding bugs. So the effectiveness question that we can answer is, what percentage of bugs do we find? Now obviously not 100%, but we want it to be most. So the metric that we would look at there is called the defect detection percentage. You can see it's defined here. DDP is equal to the number of bugs detected divided by the number of bugs present. So if we're talking about testing, and testing in the sense of it's the testing that happens right before we go out the door, then we would say, okay, we look at the number of test bugs, divide that by the number of test bugs plus the number of bugs subsequently found in production. That's our DDP for testing. Now, obviously, you need to wait some period of time after the testing is over and the product is in production before you start to measure the production bugs. On the day you go live, your DDP is going to look real good. It's going to be 100%, but you have to give it some amount of time. Typically, there's some characteristic period, say 90 days, 30 days, 2 weeks, so it depends on the adoption rate of your users, during which 80 or 90% of all the defects will be reported, are reported. So for a given release, you can measure the DDP by just waiting some number of weeks after the release and then counting the production bugs. Steady state, for a lot of our clients, they measure the DDP on a rolling basis using data from the last year. And what tends to happen there is that tends to work out pretty well. If you look at all the bugs found by testing in the last year and all the bugs found by production in the last year, then that tends to be a pretty good approximation, because it tends to include a certain number of test bugs for which no production bugs have been filed yet because it's a new release, but it also includes production bugs for which the test bugs are no longer being counted because it's an older release, so it kind of comes out in the wash. Now, what should your goal for this be? Well, a typical number when we do assessments is about 85%. Some teams do better. Some teams do a little worse. We've certainly seen clients that have gotten this as good as 99% on a fairly consistent basis, though that is not easy to do. Now, not only do we want to find bugs, typically we also want to find the most important bugs. So, are we finding more important bugs than less important bugs? This is a question of, are we focused? Are we effectively focusing our effort? So the metric that we can use here is looking at the relationship between the defect detection percentage for the critical bugs, however we want to define those, the ones that are important, versus the DDP for all bugs. The DDP for the critical bugs should be greater than that for all bugs. In other words, we find a greater proportion of critical bugs than we do overall. So that relationship shown below should be true. Now, what we tend to find with clients that are not practicing risk-based testing is that actually it's the other way around. So, risk-based testing is a real good way of making sure that you're focused on the right stuff. I've done a number of presentations on risk-based testing, so I'm not going to go off into that realm here, but if you're interested, there's at least one recorded webinar that's directly pertinent to risk-based testing that you can go and access. And in addition, there are a whole bunch of videos that you can access on the digital library. So if you go to the rbcs-us.com page and select that resources tab in the upper middle of the page, you'll see it pulls down a list. Digital library is one of the things that you can access off of that list. And there's probably about 3 or 4 hours of videos out there about risk-based testing and how to do it. So I'd encourage you to go take a look at those.